Hello everyone and welcome to a new episode of All Things IDA. In this episode we're gonna dig deeper into the functions.hpp but basically in the Python counterparts. Gonna cover all the functions that are relevant, most used and so on. Of course, a header file is big, it has so many functions, but hopefully we cover what you might be needing in day-to-day tasks. All right, let's get started. So since we're talking about IDAPython, the first thing I'm going to do is go to the source, so the SDK. And I'm going to open funcs.hpp and quickly I'll give you a quick overview. So the first thing really we're talking about is the function class. In the function class, a function has flags such as function no return, var, is it a library function, does the function use a frame pointer? Is it hidden? Is it a sunk function? Just a jump? And so on. And so those flags really correlate to if we pick any function from this database and edit it with Alt P, the flags of the function correlate visually to those checkboxes here. And same, some of the function attributes, such as like function start and end, and some of those numbers here, all are defined inside the function object. So let's get started with the basics. So the first thing is we're going to cover how to enumerate functions. But before that, I'm going to work with a single function. So I'm going to just pick a function. The first thing we can do when we work with functions, so here let's say func1, that's my snippet. Or before we use the snippet, let me rename this to f1. For now, the first thing you need to do is to get a function object in Python. So the first thing is we can say IDAPython.getFunc. Now where does getFunc come from? So let's go to getFunc and show you what the getFunc does. GetFunc, we give it any address, any function, and then we get the function object. So here we say getFunc, any address. Usually we use the getScreenEA or idc.here. And then we can say, let's put this in a function so we can return easily, and let's invoke the function. And here we can say if not f, we can, for example, this is a very common pattern. We can tell the user that not inside a function. So for example, before decompiling a given address, we want to see if there's a function created. So this is the first check. Maybe just to be useful, we can display the message. And for now, we'll just return true, and let's say print OK. And then I'm going to clear the screen and run the program. So here we are in a function. We got the OK pass. Here let's return false. I'm gonna quickly delete this function, and now we don't have a function. And if I rerun it, it should give me an error that not inside a function. So I'm going to recreate the function pressing P. And that's the first thing really. We need to get the function object or any address inside a function. Now that we got the function object, we can do some stuff. For example, we can get the start of the function and the end of the function. So we can get the start boundary and the end boundary. So let's func start. And to access the function start, just to show you how I am able to answer those questions. So I always refer to the SDK. A function subclasses from range, so it inherits start and end. So we can safely say f.startEA and f.endEA. Let's run it, format it here, run it. So now here we got the function start and the function end address, basically, just after that. So this is the first thing. Similarly, we could also say print function flags, f.flags, and if we are so inclined, we can decode those flags. For example, 5400, we can quickly go to the flags. For example, 54, this and this. Sorry, 5, this, and the 4 here. 00. Let's make it a library function quickly. Let's mark it as a library function. We can test this value. It should become 5404. So I'm going to edit the function and make it a library function and press OK. Now, of course, as well, the color changes because IDA has a special color for library functions. Now, if I rerun the script, we can see here this 4 is from the flags. Of course, now, we can always then test for the flags. So we can say if f.flags and IDAPI.func lib, then, for example, we can display this message. And if we go to another function that's not a library function, rerun the script, it doesn't display this. Now, let's do some other things. I cannot, let's take the base. So the base is always getting a function. Now I'm gonna assume I'm not gonna be checking if it's a function. I'm gonna assume now we're always working with a function. So let's get a function pointer from wherever the address is. Let's spice it up and use some other APIs similarly. So I'm gonna try to keep on mixing and matching APIs. I'm not gonna check for f is none. I'm gonna assume f is not none. Run it. Now f is in the global scope. So if I go back here to the CLI and type f, I have the same. So that's a very useful tip, I would say. So you might be wondering, okay, so how can I get the function name? And let's call this f2. And if we say f.start EA, we get this. And now the question would be, do we have f.name? No, we don't have f.name. So for that, we'll have to use the name.hpp functionality. So for example, to get the function name, if we start with any address, we get the and then say get function, we get the function object. Then we can access the start EA and pass the start EA to the get name method. So IDAPI.get name. Let's see here. So get name, we give it the address. It gives us a string. So if I go here and put the string EA to be any address in the function, we can still get the function object. But if I ask get name for EA, of course, unless there's a name at the address, I won't get anything. So this will not directly give me the function name. Instead, I have to say f.start EA. And I can say now func name is, and we should be able, let's clear the screen. And here we got function name is f2. So we got the function name. All right, what else? Let's talk about function enumeration. How can I enumerate all the functions? So here we have 2,400 functions. Let's create a new here enum funcs. So we have as well many methods to enumerate functions. For example, we have get func quantity. So print, we have IDAPI get f quantity, func quantity. Let's just run it. So we got the same result. Great. Now, with the quantity, we can start to enumerate by index. So here, let's put it as a variable. And now we can say for I in range quantity, Now we need to get the function by index. We can use get enfunc. We give it an index. It gives us the function name, the function pointer, so or the function object from Python's point of view. And we can, for example, by the way, real quick, I was showing you about the flags, and we can manually check the flags, but there's also helper methods for the function objects. So like funclib might or might not have a helper function, but some of them have, like isFar. We don't have to check for funcFar, does return. So we can access those stuff. Let's test real quick. So f is still there, f dot does return. Indeed, does return. How do we know does it return? It has nothing to do with the return instruction. You can make this function no return, although it does return. So if I edit the function and press Alt-O, or just here, does not return, then this function now is marked as no return. So let's say we want to enumerate all the functions that do not return. All right, so quantity and f equal, and then we can check if it's a library function. If, let me double check. We check that this one doesn't have, so we'll have to, or does not return. Let's just not check for library functions. I think there is not many library functions. We can see some of them. Maybe we can count them actually. Libfuncs does not return funcs. So if f dot does return not, then does not return funcs, and then if f dot flags and funclib, then libfuncs equals 1, and finally let's print the counts. For example, we have libfuncs library functions and dnr funcs do not functions. Okay, let's it should be fast, so if I run it, we should get the result real quick. Of course, I can also print in between. I can print what are the addresses, or maybe I can actually append them to a list, and so that's our first kind of walkthrough. So we enumerate the function by getting getting the range, by getting the quantity, and then getting a function by index to get the function object, and from there we go back to what I showed you earlier. Getting a function, inspect its start EA and EA and whatever. But it's always important to have a function object. And the second most important thing about the function object is the start EA, because given the start EA, we can always go back to a function object. So it depends. If let's say we want to store information in the database to come back later, we can't store a function object. It's not necessarily serializable. Instead, we can store the function start address, and later we can pick it up, recompute the function object, and use it. So those function objects, you can think of them as fleeting objects. They do not persist. So it's best to store the function start. Especially, you might be wondering in C++ what's happening when we say get func and we get the function pointer. You might be wondering, are we really getting a real function pointer? Is it allocated? Is it borrowed? Is not necessarily given to us. So I can tell you this is borrowed, and it's also coming from a static array of functions inside IDA. So there is a limit inside IDA. We cannot hold on to 1000 function object. Eventually, the internal static round robin buffer will go back to 0 and start recycling the function object. So storing the start address of a function is a good thing. So every time we get the func. Imagine that the function object lifetime is short-lived, maybe within the function that you're using, the Python function that you're using, the function object. Another way to enumerate functions and do other things is to use idautils. So if we import idautils, and let's also show you idautils. So in idautils, we have a functions generator that we can optionally give it start and end ranges if we want to enumerate functions within a boundary. And we don't have to pass those boundaries, but otherwise, if we don't pass them, they will be retrieved from the minimum address and the maximum address. Now, to use that generator, all we have to do is, let's print all the function names. So for funcEA in idautils.functions, so functions gives us the start address of a function. Now we can resolve, if we want, a function object. Also, I don't want to inspect the flags or anything. Maybe I don't want to get the function object. I'll just show you that we can get that function object and inspect anything we want. Maybe it's end EA, it's flags, and there's so many other attributes inside the function. So I just want to display the names. So idapi.getName f funcEA. And maybe let's get it and display the range. So I'm gonna display like this. There is no need to check if getFunc is gonna return none because we know we got it correctly from a proper address, which always gives us the start of functions. Now we can say, let's say name, f dot start EA to f dot end EA to end the name. Let's say name here. Okay, that's a good output. So now here, for example, we can see every function and its boundaries. All right. Now we can enumerate functions. We know about the function object. Now let's dig deeper inside the function. Now, what do we have inside the function? If you recall from a previous video where we spoke about database items, so items inside the function are also database items, and they can be instructions, undefined, and data. So we can have undefined, same story as before. We can have data, and we can have code, and that code would be part of the function. But so that's unexplored, data, and so on. And similarly, because we're dealing with items, we have item heads, tail, and so on. So now the question would be, how can I get all those code items, for example, in a function? Now, you can be creative. We covered instruction decoding. You would say, I'm going to get the start address of a function and address, and I'm going to decode the first instruction and increment by the size of the instruction all the way to the end. You would have done something like this. You'd say, okay, I'm inside a function. You get func, and you can ask for the current screen address. And you might do something like while, let's say, end EA equal f dot end EA, EA equal f dot start EA, while EA and EA. Let's try to find some small function. So let's see here. Len, let's take a small function. Of course, I'm not looking for stubs, but so slightly bigger than those stubs. Okay, that's a good one. And here we can say instruction equal idautils dot decode instruction at EA. Let's not forget to advance by instruction dot size, and if not instruction, let's break. We could not serially go back and decode. And now this we can maybe print this assembly line if we wish for every single line and so on. Let's see. So IDC dot get this ASM, and so here, for example, I can print the EA and the IDC gets this ASM at that address. This is not, this is one way, of course, but as you see next, it is a wrong assumption to rely fully on start and end EA. This is not correct. It's correct in certain cases, but not in all cases. Like in this case, yeah, this is a complete function that goes from a lower address to a higher address. That's fine. But we might have chunked functions or functions with their basic blocks that are all over the place. Could be the function starts at a high address and then the function, so we could have a function that we find it somewhere in the code. That function then suddenly jumps to a lower address. And then that block jumps somewhere at the end of the address space and it goes back and forth, and so on. This could be due to many reasons. It could be obfuscation. It could be compiler optimization, like tail optimizations and whatnot. So relying on start and end is not solid. All right, let's test this piece of code. Let's clear the screen and run it. So here we went all the way, replicated everything that we got the disassembly lines and so on. So that's it for today. I hope you found this video useful. If you liked it, press the like button, and if you want more of those videos, please subscribe. Or if you have questions, please leave them below in the comments, and I'll be seeing you next time. Thank you.